Welcome to the NPTEL online certification course. The title of this course is Digital Control in Switch Mode Power Converter and FPGA-based Prototyping. I am Dr. Shantanu Kapat, an Associate Professor in the Department of Electrical Engineering, IIT Kharagpur. In this course, we are going to first show the digital control trend in power electronics industry, and I am showing few examples. One of the example is for cloud computing for low voltage high current application, where the voltage level can be around 1.8 volt or below, but the current can be more than 1000 ampere. So, where the digital control can play a significant role. So, one of such example is Renesas digital power solution. Then ST microelectronics digital power solution for server, where you can have a AC to AC, AC to DC, then DC to DC, and then DC to 48 volt to POL solution, which can be a digital solution. Then another example is a Texas Instrument digital power solution, where you can have one IC can be used for various power converters solution. Then one of that is Infineon digital power for LED driving application. So, these are the few examples out of many such digital control product from this company as well as the other industry. Now, why there is a growing emphasis on digital control? Because the design can be made flexible, it can be portable and reconfigurable. Particularly the same digital control platform can be used for various topology. Then if you go for HDL based implementation coding development, which I will be showing in this course thoroughly, this can be imported or it can be mapped to different process technology. Then digital communication and control, let us say for example using PM bus solution. So, you can make the power supply network, the whole power supply network reliable, fault tolerant, and it can have a smart power supply network. Then you can have integrated hardware, software, firmware solution, where you can optimize the power converter from starting from the switch level, for example using active gate drive to the full converter level. It can be multiple converter for, let us say, for onboard charger application, and you can have a third party interface. You can achieve higher efficiency, lower component count by integrating all the controller using a single chip, and you can have advanced control for fast transient. There are different levels of digital control product. One can be digital power management IC, only one IC with off chip inductor and capacitor. You can have a single digital controller IC for, let us say, for multi-phase application, where there can be smart power phases, and one digital centralized controller can actually control the whole multi-phase converter. Or it can be plug and play off the shelf digital control product, where for example in onboard charger you can use a microcontroller or some other application, where you can just plug and play module can be used. And this using digital control, you can cut down the technology development as well as the product development time. So, you can reduce the time to market. Some of the example I am just showing DC-DC buck converter, and here in this course we will be using lot of hardware demonstration, and these prototypes will be used like a buck converter, then Xilinx FPGA kit will be used, and signal conditioning board. So, this is a complete test prototype that will be used in this course. Then nothing comes free of cost. So, digital control requires some A to D or D to A converter, but there are scope for optimization in terms of number of ADC or DAC. You can optimize the number of bit count, then you can also optimize the sampling rate as well as the computational time. And the level of digitization, you can start with a very basic analog control with housekeeping in the digital. For example, you can keep some reference programming feature in digital, which can be used for devious application, but the controller in analog, the control loop is analog. Or you can keep some part of the loop in analog, which are the fast changing signal, and some part in digital, or you can have a fully digital solution. Similarly, apart from this implementation way or digitization, you need various kind of modulation technique, whether it is a fixed frequency, variable frequency modulation. What should be the sampling rate? Should you use uniform sampling or should you use event based sampling? Should you use one sample per cycle or should you use multiple sample per cycle? This issue will be discussed along with the implementation platform, whether it is an analog domain or a combination of analog and digital domain. Then the power consumption is very important. Then we need to consider right sampling rate and also the right resolution, which can reduce the loop delay, at the same time power consumption. There is a trade off. Then within this constraint, we need to analyze their different stability aspect come because of the discretization. So, we need to know about modeling, analysis and design methodology, and then the design is in the mixed domain, some part is digital, some part is analog. So, we need to know how to actually, I will be emphasizing HDL based coding which can be mapped into ASIC solution. Why is this course? This is a 12-week course and this is to familiarize various digital control architecture under resource constant for the commercial product. Then we will learn a lot of analysis and design tool. I will introduce HDL based coding, Verilog HDL based coding and fixed point implementation and FPGA prototyping. In this course, I will demonstrate various hardware prototype using Xilinx FPGA extensively, and I will also consider various video for digital control implementation using microcontroller, and I will be using mainly there is one or two popular microcontroller like STM32 and C2000 series, and the design expert from ST Microelectronics and Texas Instruments will be demonstrating. I will also present a lot of MATLAB customized model development as well as the design validation methods, and this course will be useful to develop skill manpower as well as it will enable to develop indigenous IP. Who can attend this course? This course is designed for the engineer for power electronics and power management industry, but they should have a minimum undergraduate degree in electrical or allied branch. Then MTech and PhD student working in the area of power electronics, power system, control system, automotive electronics as well as embedded control system should be benefited. Then undergraduate student who has basic power electronics course and as well as the faculty member working in the area of power electronics should be benefited. So, with this I want to encourage to register for this course. Thank you very much.